Namaste, welcome to our YouTube channel LKG Last Night Guru, where night starts from K and K stands for knowledge. Today's topic is Prim's algorithm. This algorithm comes under greedy approach. Okay. So this Prim's algorithm, let us understand the problem statement of this Prim's algorithm. Why we use this Prim's algorithm? Okay. See, this Prim's algorithm is used to find minimum cost spanning tree. Okay. This Prim's algorithm is used to find minimum cost spanning tree. Okay. The problem statement of the Prim's algorithm is to find minimum cost spanning tree for this graph. It might be any graph. For a graph, we need to find the minimum cost spanning tree. Okay, we already know what is a spanning tree. What is minimum cost spanning tree? Minimum cost means the tree which we draw or the tree which we get as an output should have a minimum cost. Okay, see, the basic problem statement we can tell it in this way also. Like, we'll start from one node and we will cover every other node, right, exactly once, so that the total cost will be minimum. That's it. Alright, so we will try to solve this Prim's algorithm using our formulas and tables. So let us start our table. Alright, so the first column of our table is our source. The first column of our table is our source. The second column is V is equals to V minus S, where V is nothing but your vertex or a node, right? S is nothing but your source, right? So next one is D of V is equals to minimum of D of V, comma, cost from U to V. Cost from U to V. And the last one is parent of V. Last one is parent of V. So we have four columns here. This is source, V is equals to V minus S, and this, and then this. So first we will try to solve this table. See, first, to choose a source, correct? To choose a source. Source will not be given in Prim's algorithm, alright? Source will not be given in Prim's algorithm. You need to find which one can be the possible source, okay? See, how to find the source. If you look at this graph, what type of a graph is this? This is a cyclic graph, this is a weighted graph, this is an undirected graph, right? So in this graph, which two nodes is having the minimum cost? Okay, why we are finding the minimum cost? Because this algorithm comes under greedy technique, alright? So in greedy technique, what we will do? We will find the minimum cost first, alright? So when we are finding the minimum cost, out of all these costs, see, the costs are one which are marked in our red marker, right? So these are nothing but the costs. From 0 to 1 it is 60, from 0 to 2 it is 10, from 2 to 5 it is 50, right? So out of all this cost, which one is the minimum? Yes, 10 is the minimum, correct? 10 is the minimum cost. So it is from 0 to 2 as well as from 2 to 0, because it is an undirected graph, correct? It can be 0 to 2 and also from 2 to 0. So this is the minimum cost that we are having. Correct. Now, either we can choose 0 as our source or also 2 as our source. That is left to the student. Alright. We can choose either 0 as our source or 2 as our source. Alright. So, we will go in the ascending order. So, we will choose 0 as our source. I will choose 0 as our source. What are the remaining vertex after 0? The remaining vertex are 1, 2, 3, 4, 5. These are my remaining vertex, correct? Apart from 0, what are the remaining vertex? 1, 2, 3, 4, 5. These are my remaining vertex, correct? Okay. Now, D of V is equals to minimum of D of V, comma, cost of U to V. So that is our formula. Let us see what is D of V. D of V is, first we need to find the cost from D of 1. We need to find the cost of D of 1. Before that, we need to allocate some of the cost for this nodes, right? See, whenever you are taking source, right? Whenever you are taking source, the cost of this will be 0. The cost of this source will be equal to 0, okay? Now, apart from that, every other node's cost will be infinity prior, right? before solving, every other node's cost will be equal to infinity. Okay, so with this cost we will try to solve this. All right, see, d of 1 is equals to minimum of d of v. What is the d of v? D of v is the cost of this node. Cost of which node? First node. What is the cost of this node? It is infinity, comma, cost from u to v. What does cost from u to v means? From source to destination. Which is my source? 0 is my source. Which is my destination? 1 is my destination. From 0 to 1, what is the cost? Which is marked in red marker. Yes, exactly, 60. Correct? Now, minimum of infinity and 60. Which is the minimum of infinity and 60? Obviously, 60 is the minimum. Getting my point? It is very easy. Same way, we need to find for the remaining vertex also. Now, for d of 2, correct? For d of 2, minimum of, what is the cost of d of 2? Cost of d of 2 is infinity, which is marked in green marker, right? Then, what is the cost from 0 to 2? 0 to 2, the cost is 10. So, minimum of infinity and 10, it is 10, correct? Next comes d of 3. D of 3, minimum of, what is the cost of d of 3? Infinity, comma, what is the cost from 0 to 3? 0 to 3, there is no any direct route. That's why this cost will also be equal to infinity, and this also will be equal to infinity. Next comes d of 4. Minimum of, what is the cost of d of 4? Earlier it will be infinity, comma, 0 to 4, no direct route. So this will also be equal to infinity. Same thing for d of 5. Minimum of infinity, comma, 0 to 5, is there any root? No. So this also will be equal to infinity. So this completes our first iteration. This completes our first iteration. Now what we need to do? Look carefully here. Out of all these costs, which one is the minimum cost? Yes, exactly. 10 is the minimum cost. Alright. So for which node we got the 10 as the minimum cost? That is for 2. Node number 2 we got 10 as the minimum cost. So which will be our next source? Yes, obviously my next source will be 2. So we completed 0 and the next source will be 2. What are the remaining vertex? 1 is there, 3 is there, 4 is there and 5 is there, because 0 and 2 are there in the source. Okay. Now before heading to the next operation, what is the one more thing that we need to do is we need to update the cost in our graph. Right? We need to update these cost in our graph. Right? See, now what is the cost of d of 1? D of 1, the cost is 60. We got minimum is 60. But what was the earlier cost here? It was infinity. Correct? So look carefully here. I need to update this cost from infinity to 60. Correct? Now for d of 2, I got the cost as 10. So I should update this cost as 10. Remaining infinity, 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 infinity. No need to change. Alright. So whenever you got this minimum cost, you need to change that. Alright. And one more thing that we have left is our fourth column. What was the fourth column? Fourth column we got 2, right? So now this becomes parent of node number 2 is 0. What does this mean? P of 2 is equals to 0. Parent of node number 2 is 0. That means that to reach this node 2, from where we need to travel? We need to travel from 0 to 2, not from 1 to 2 or 5 to 2. Correct? We need to travel from 0 to 2. That's what the fourth column represents. Right? Now coming to the second iteration. Second iteration, same thing. D of 1, because we need to find this. So D of 1 is equals to minimum of, now look carefully here. What is the cost of D of 1? Earlier it was infinity, but now it got updated to 60. Correct? Minimum of 60, comma, from where we are finding cost of u to v. Which is our u and which is our v? U is nothing but your temporary source. Which is your temporary source now? 2. You need to find root from 2 to 1. 2 to 1. Is the direct route? No, there is no direct route. So this will be infinity, but the minimum will remain as it is, that is 60. Now coming to d of 3. d of 3 is equals to minimum of, what is the cost of d of 3? d of 3, it is still infinity only, comma. Can we go from 2 to 3? No, we cannot go from 2 to 3. That's why this is also infinity. So minimum is also infinity. Now d of 4, right? d of 4, minimum of, what is the cost? Infinity, right? Minimum of infinity, comma. Can we go from 2 to 4? No, we cannot go from 2 to 4. That's why this is also infinity. This is also infinity. Next comes d of 5. d of 5 is equals to minimum of infinity, comma. Why infinity? Because cost is infinity. Can we go from 2 to 5? Yes, we can go from 2 to 5. What is the cost? The cost is 50. Yes, I can go from 2 to 5 and the cost is 50. So the minimum is also 50. Now what we need to do? We need to find minimum amongst this. We need to find minimum amongst this. Which is the minimum? Of course 50 is the minimum. For which node? It is for node number 5. So which will be my next temporary source? 5 will be my next temporary source. 0 over 2 over now 5. And what are the remaining vertex? 1, 3, 4. Correct? 1, 3, 4 are the remaining vertex. Now I need to update this cost in this graph also. That is also one more step, correct? See, for node number 1 it is 60, here also it is 60, no need to change, correct? Node number 3 it is infinity, node number 4 also infinity, node number 5, d of 5, what we got cost as 50, but earlier it was 5, change this to 50, correct? Now for the fourth column, what is the fourth column? Parent of node number 5 is equal to 2. Parent of node number 5 is equal to 2. That means that to reach node number 5, from where we need to reach? We need to reach from 2 to 5 only. That will give the minimum cost. Alright? Okay. So now we will carry on this iteration. So our new source or the temporary sources node number 5 and we need to do 3 iterations, right? That is for node number 1, 3 and 4. Now let us start from node number 1. d of 1 is equals to minimum of, what is the cost of d of 1? Cost of d of 1 is 60, comma. What is the cost to go from 5 to 1? 5 to 1 the cost is 70, correct? 5 to 1 the cost is 70. Can we go from 5 to 1? Yes, we can go. What is the cost? 70. Which is the minimum of 60 and 70? Minimum is obviously it is 60 still, correct? Now next coming to d of 3. Coming to d of 3. Minimum of, what is the cost of d of 3? It is still infinity, comma. What is the cost to go from 5 to 3? Why 5 to 3? Because 5 is your source, right? 5 to 3 the cost is 80. 5 to 3 the cost is 80. So this will be updated to 80. Minimum is 80, right? Next coming to d of 4. Coming to d of 4. We should find minimum of, what is the cost of d of 4? Infinity. What is the cost from 5 to 4? 5 to 4 the cost is, look here, 5 to 4 the cost is 30. 5 to 4 the cost is 30. So that's why this will be equal to 30. Now what is the next step? We need to find minimum amongst this. Which is the minimum? 30 is the minimum. What is the node? 4 is the node, correct? So what will be my next source? 4 will be my next source, correct? 0 is over, 2 is over, 5 is over. Now what is the next source? 4. What are the 2 remaining nodes? 1 and 3. Now we need to update this cost in this graph also. So for node number 1 it is 60 only, do not change that. For node number 3, what we need to write? 80. For node number 3 we need to update this cost to 80. For node number 4 we need to update the cost to 30. Right? We need to update the cost to 30. Now for the fourth column, parent of 4, correct? Parent of 4 equal to, from which node we reach to 4? From 5th node. Parent of 4 is equals to 5. Parent of 4 is equals to 5. Right? Now coming to the next iteration. Right? d of 1, again we need to find from d of 1 only, but this time from node number 4, correct? Now d of 1 is equals to minimum of, right? d of 1 is equals to minimum of, what is the cost? 60, comma. From 4 to 1, what is the cost? 40, right? Which is the minimum? 40 is the minimum. See, now the cost got updated for 1. Earlier it was 60. Now we got one more less, that is 40. Now, next comes D of 3. That is minimum of, what is the cost of D of 3 now? D of 3, the cost is 80, comma. From 4 to 3 is the root? No, that is 80, comma infinity. Which is minimum? 80 itself is the minimum. Now, out of these two, which is the minimum? 40 is the minimum. For which node? It is node number 1. So 1 will be my what? Next source. That is 0, 2, 5, 4, 1. Correct? And the only remaining vertex is node number 3. Now I need to update the cost in graph also. So node number 1, what is the cost? 40. Node number 1, the cost is 40 now. Node number 3, the cost is 80. The cost is 80 only. Do not change that. Alright? Okay. Now, next we need to write parent of which node? Parent of node number 1. Right? Which is the parent of node number 1? It is 4. Parent of node number 1 is 4. Right? Okay. So, the parent of node number 1 is 4. Okay. Next, coming to this one. D of 3. D of 3 is equals to minimum of, what is the cost of D of 3? The cost of D of 3 is 80, comma. What is the cost to go from 1 to 3? 1 to 3, the cost is 20. So, which is the minimum? 20 is the minimum. Correct? 20 is the minimum. There is only one iteration because there was only one thing. Right? So, now 20 is the minimum cost. Correct? So, which is that node? The node is node number 3. So, node number 3 will be my next source. 0, 2, 5, 4, 1, 3. And here there are no nodes to visit. That means that we need to end our iteration here itself. Alright. Now, update this cost to, from 80 you need to update this cost to 20. From 80 you will update this cost to 20. Now, the parent of 3, correct? Parent of node number 3 is 1. Parent of node number 3 is 1. So, this completes our Prim's algorithm, right? Now, what is left? We need to write the answer and we need to draw the minimum cost spanning tree. What is that? Minimum cost spanning tree. Okay. So, let us draw the minimum cost spanning tree with the help of this fourth column. What is this fourth column? Parent of V, correct? So, with the help of this fourth column, we will solve this minimum cost spanning tree. So, this was the fourth column which we got, right? This was the fourth column which we got. We got how many? 1, 2, 3, 4, 5. We got 5 edges. This is nothing but your path or edges, right? So, we got 5 edges, right? And what should be the number of nodes? Obviously, the number of nodes was equal to 6, correct? The number of nodes was equal to 6 and the number of edges what we got is n minus 1. That is nothing but 6 minus 1. We got 5. We got 5 answers here. That means that our answer is correct. That is what is the definition of minimum cost spanning tree, right? For minimum cost spanning tree, there should not be any cycle in that and the number of nodes should be exactly equal to the number of graph and number of edges should be exactly 1 less than number of nodes. So, our answer is correct. Now, we need to draw this minimum cost spanning tree. Now, look at this. Parent of 2 is 0. That means that, see, I will draw the node number 2. For node number 2, what is the parent? The parent is node number 0. Getting my point? Parent of node number 2 is 0. Simple thing. Parent of node number 5 is 2. That means that I need to connect node number 5 to 2. Parent of 4 is 5. Parent of node number 4 is 5. Correct? Parent of node number 1 is 4. Parent of node number 1 is 4. Correct? Parent of node number 3 is 1. Parent of node number 3 is 1. So, you can draw this minimum cost spanning tree in any way. Alright? So, this is the minimum cost spanning tree which we have got. Now, what is the minimum cost that we are having? Simple thing. What is the minimum cost we are having? From 0 to 2, the 0 to 2 the cost is 10. From 2 to 5 the cost is 50. From 5 to 4, 5 to 4 the cost is 30. From 4 to 1 the cost is 40. And from 1 to 3 the cost is 20. Now add all this, that is 10 plus 50 plus 30 plus 40 plus 20, correct? So 10 plus 50 is 60, 60 plus 30 is 90, 90 plus 40 is 130, 130 plus 20 is 150. This is nothing but minimum cost. This is minimum cost. And what is this? This is nothing but spanning tree. What did we get? We got minimum cost spanning tree. This completes our Prim's algorithm. So simple. Alright? Okay, let us recall whatever we have studied now. See, Prim's algorithm comes under greedy technique. Alright? Prim's algorithm comes under greedy technique or greedy approach. Why? Because when we are choosing our source, correct? When we choose our source, we choose the minimum cost. What is the minimum cost? 10 was our minimum cost and we choose 0 as our source. That's why this comes under greedy approach, right? And why Prim's algorithm is used? This is used to find minimum cost spanning tree of a graph. See, for this graph, we find out this minimum cost spanning tree. Very simple, alright? So this is the algorithm for Prim's, right? Same way, there is one more algorithm that is called as Kruskal's algorithm. Kruskal's algorithm and Prim's algorithm are used for the same problem, right? That is also is used to find minimum cost spanning tree. The only thing is the approach is different, right? So this completes our Prim's algorithm. In the next video, we will look at more concepts of design analysis of algorithm. Until that, keep sharing this video. Thank you.